Creating a frequency distribution. This is coming from Chapter 2, Section 1. Frequency distribution. So this is a table that shows either classes or intervals, or if you've taken a previous Intro to Stat course, you might have heard it called bins, of data with a count or a number of entries in each class, also known as your frequency. So this is a way to group our data so that you can kind of see trends in these groups over the whole data set. So this is what we are going to be making, is this image right here over on the side. The frequency F of a class is the number of data entries in each class. So the thing that we lose when we start grouping data is we can see that there's 5 things that came up between the number 1 through 5. We just don't know what they were anymore. So were they the number 1 that came up 5 times? Was it a spread of numbers, 1, 2, 3, 4, and 5 that came up, or were they all 5? We don't know anymore. We just know that 5 were in that range from our data set. So each class has what's called a lower class limit, which is the smallest number that can belong to that class. And then you have an upper class limit, which is the greatest number that can belong to that class. The class width is the distance between the lower or upper limits of consecutive classes. So on your PowerPoint slide, they show it as a subtraction of the 2 lowers. 6 minus 1 means the class width was 5. The difference between the minimum and the maximum data value is called the range. And for short, we write that formula out as max minus min. So these are the 5 steps to create one. You have to first decide on a number of classes, usually between 5 and 20. Otherwise, it's hard to see patterns. Think of this as long-term, we can turn it into a bar graph. So 5 bars, 20 bars, more than that would just be too much. Smaller than 5 is just not enough to look at. Now, for this piece and for this course, this piece is given to you. It's going to be somewhere in that wording of the problem, but the number of classes will be given. Step 2, find the class width. This is for you to do. You're going to find the range of your data, so that max minus min, and then you're going to divide it by the number of classes that, again, was given to you. And then whatever you get, you are going to round up to the next convenient whole number. Now, I marked that round up often there because it is always rounding up. It's not rounding down. So whatever your decimal value is, you're going to round it up no matter what to the next whole number for your class width. Then you're going to find your class limits. So you're going to use your minimum data value as your first number in your lower class limits. And then you're going to add your class width down the column. Across the diagonal, you can find that upper class limit, or you can add in your class width minus 1 from your lower class limit. You'll see what this looks like in just a moment, but you want no overlap. So none of these numbers should match a different row. Fill in the remaining upper class limits all the way down the column. Now at this point, your class column is fully done, but you've got to fill in your frequency column. So I'm going to put up step 5 and step 4 here because you can really kind of do these both at the same time. You can do a tally mark for each one of the data entries as you're trying to figure out how many is in each row. Or you can just count how many there are and total it up and put it in without having to do the tally mark. Tally mark is just a method of counting them to keep yourself organized. In case you haven't done tally marks in a while, which is what I typically notice in the classroom when people are doing this. When you're counting with tally marks, you count 1, 2, 3, 4. The 5th one is when you slash. So that way, when you go back later and you are counting the number of tallies, you can count them by 5s. It just is an easier way of counting them. Again, you don't have to use tally marks. You can just count them from the data set to get that number. So here's our example. The data set lists the out-of-pocket prescription medicine expenses in dollars for 30 U.S. adults in a recent year. Construct a frequency distribution that has 7 classes. Notice I told you it was going to be given to you. And then a lot of data there. So we're going to go step by step through those 5 steps to create a frequency distribution. So step 1 was the number of classes, and they told us 7. Now to find the class width, you start by finding the range. So I need to know what is the max and what is the minimum. And keep in mind, anytime they give you data sets, they are most likely not in order. So you kind of have to skim through a little bit. I think 155 might be my smallest. That's my minimum. All right, let's look for maximum. $405 is our biggest one in there. So that's our max. So first step is find that range. 405 minus 155, we get a range of 250. Now we need to take that range divided by the number of classes. So we take 250 divided by 7. And your calculator will give you something like 35.714 on. And we always, I'm going to even put it here, round up. So we're going to round it up to 36. That is your class width. So now to make this, I'm going to make it right here next to it. We've got our class and our frequency column. Our class column, the first number is going to start at our minimum. So our minimum was 155. And then down the column, this way, down this way, you are going to add in the number 36. So 155 plus 36, which is your class width, gives you 191. That would be your next row. Then add 36 again. Add 36 again. And you're going to keep repeating this, adding 36, because that's your class width, until you have 7 rows. 7 rows, because that's the number of classes they told you. Class is the same thing as saying rows, the number of rows they want. So I need one more. 371. So I have all of my lower class limits. Now I need to do my upper class limits. So the easiest way to do this is to look at the diagonal. So 191 is where the second row starts. So that means the first row has to stop 1 notch before that. So 190. It's 1 number down from where the next row starts. So the third row starts at 227. That means the second row has to stop at 226. So each one of these can be written from looking at the diagonal and subtracting 1. Now, the only thing that doesn't help you with is that bottom one. But if you go back and look at the pattern, once you had that first number in there, that 190 at the top, if you add in the class width again, add in the 36, you get 226. And if you add in 36 again, it's the same pattern down this whole column. So when you get to the bottom, take that 370 right here, add 36 to it to get our last number, which happens to be 406. Now we have all of our classes done. So now we need to go back and do frequency. So this is where you can do the tally marks if you want, or you can go through and count them. If you have it printed in front of you, or if you write down all the numbers down on your paper in front of you, I find it easiest to just go through and count. That's a personal preference for me. If you like tally marks, go for it. But for me, what I'll do is for that first row, I'm going to look through my data set and look for all the numbers that are 155 to 190 and count them. And I'm going to slash through as you go so we can see what I'm doing. So I'm looking for 155 to 190. So here's 1, 2, 3. I only see 3. So I have a frequency of 3. That's how many times those numbers came up in my data set. So then I start my next list, or my next row here, 191 to 226. So I've got 1, 2, just 2. I'm going to repeat this process going all the way down. So now I'm on 227 to 262. 1, 2, 3, 4, 5. I have 5. All right, now we're looking for numbers between 263 and 298. So any number in that range, we're going to slash through as we count them. 1, 2, 3, 4, 5, 6. All right, now we are up to 299 to 334. 1, 2, 3, 4, 5, 6, 7, 7. Almost there. So 335 to 370. 1, 2, 3, 4. And the last one, 371 to 406. 1, 2, 3. Whew. It is not a quick process. Sometimes it takes a little bit to go through all the numbers. And I tried to do it as fast as I could there for you that are sitting at home and watching me. When you're done, though, the best way to check it is to add up your frequency column. So the 3 plus 2 plus 5, all the way down this column. And I get the number 30, which should match your sample size. That's the fastest way to quickly check to make sure you've got everything in there. It doesn't really check if you've got everything in the right spot, but at least it's a quick check to know, did I miss a number or did I count something twice by accident? And the slashing through also very much helps. You kind of rule them out as you go. But that is the frequency distribution that you're going to be making. Now, beyond the frequency distribution, you can do a couple more things with it. Like you could find midpoints for each one of those classes. It's like finding an average. You add the lower and the upper class limits together and divide by 2. You could also find a relative frequency, finding the portion or percentage of the data that falls in a particular class. So that is like the formula F over N. F standing for frequency, N standing for sample size. That's how you find relative frequency. And the third thing that we can do is we can find a cumulative frequency of a class. So it's like a running total or a sum of all the frequency for that class and any previous class as you go. So that the last class row has a cumulative frequency that should be the same size as your N. So we can go back and create these 3 things for the previous example that we had. So let's go back for a second. So take a moment if you want to jot down the numbers. I didn't leave as much space on this page, so I'm just copying the numbers so I have them, and then we can go back to create them on the new slide. All right, so our class column, 155 to 190, 191 to 226, 227 to 262, 263 to 298, 299 to 334, 335 to 370, 371 to 406. So all 7 classes, and then their frequencies, 3, 2, 5, 6, 7, 4, 3. All right, so the new column we can add is called midpoint. So for midpoint, you are going to take your lower class limit and upper class limit and average them. So 155 plus 190, hit enter in your calculator, then divide by 2, and you get 172.5. And it should be right in the middle of those 2 class limits. So then we can do our next one. So now we are on 191 plus 226, add them together, then divide by 2, and we should get 208.5. Now the cool thing about this is that this is going to have that same class width. So once you have the first one on there, you can take it and continually add that number 36 again. So I'll jot it up top. Remember, class width was 36. So that 208.5 plus 36 gives us our next number. And if we add 36 again, and again, we can fill in this whole column. There we go. We've got all our midpoints. The next column we can make is relative frequency. This one was that short little formula, F over N. Keep in mind, the F is your frequency column, and the N is the total at the bottom. So our total was 30. We had 30 data pieces. So our first row would be taking the number 3 from our frequency here, 3, divided by 30. And we're going to just do 2 decimals if they come up. This one's 0.1. That's coming from 3 divided by 30. Then we would do our next row, 2 divided by 30, 0.07. So you're taking each one of your frequencies one by one, and you are dividing it by the number 30. So now I'm up to 7 divided by 30. 4 divided by 30, and 3 divided by 30. This, as a quick check, should add up to 1. Relative frequency is going to come into play when we want to make a pie chart. So all of these pieces should add up to 1. And the last one we want to make is a cumulative frequency. Cumulative frequency is a running total. So your first row, your frequency should be that number frequency in any rows prior. So first row, the only first row that exists, the frequency had was 3. The second row had a frequency of 2. But since it's cumulative frequency, we want to add that 2 to any rows above it. So 2 plus the 3 gives us 5. So when you get to the third row, you're going to add the 5 plus the 2 plus the 3. You are always adding up. I'll put an arrow over here. So on the fourth row, you are adding the 6 plus the previous row's 5 plus 2 plus 3. Oop, I made a mistake there. That should be 10 for that third row. Then 16, then 23, 27, and then 30. Like the definition said, that last row should match your sample size. So once you've got a frequency distribution, you can make a couple different graphs with it, one of which is a frequency histogram. It's a bar graph that represents your data and your frequencies. The horizontal scale is quantitative and measures those data values, or your classes and your bins. The vertical scale measures the frequencies of those classes. Most importantly, all of these bars must touch. There's no gap in between the bars. Now, in order for those bars to touch, we have a term called class boundaries. That's how everything's going to touch together. So technically, we had a new whole number when we started the next row. But what happens if you have a decimal value that kind of lands in that gray area between? What do you do with it? So the numbers that actually separate your classes without forming gaps are called class boundaries, where we kind of widen your class just a little bit so that there's no gap between. So this was the chart that we had previously made. This is our class, our frequencies, and all the additional columns we added to it. If we wanted to make a histogram for this, most often we use the midpoint to mark across the bottom of our graph. So these are really your midpoint values down here. And then you use your frequency on your vertical. So 1, 2, 3, 4, etc. So your first class had a midpoint of 172.5, and it had a frequency of 3. It would have gone up to where that 3 is. Your second row had a midpoint of 208.5. It would be touching that line, and it would have gone up to a 2. And then you could repeat this pattern to make each one of your bars. Again, they should be touching as you go. A frequency polygon is a line graph that emphasizes the continuous change in frequencies. And what's happening is you get the same exact shape that you would have gotten with a bar graph. You just instead have a dot at the top of each of those bars, and you connect the line and you drop the bars off. But it is the same information of, you could use midpoints on the x-axis, and it's your frequency on your y. Relative frequency is the exact same shape and scale on the x-axis, your midpoints across the bottom, but instead of using frequency on the side, you use relative frequencies. So those are those values between 0 and 1, those decimals. And it would be the exact same height and relationship of the graph as you go. So this one says, construct a relative frequency histogram for the second example here. So we have our class boundaries. Here's the physical example of what that looks like. Each one of our lower class limits has been subtracted a 0.5 from it. So it makes it just a little bit smaller on the lower class limits. And your upper class limits have been added a 0.5. So it makes it a little wider on the right. Notice across the diagonals, the numbers match now. So if you actually had a data set that dealt with decimal values, it's a very clear, where does that number go when you round it off or have a decimal with it. Now this one says construct a relative frequency histogram. We know this data set adds up to 30. we have all of the decimal values previously found for this. So just as a reminder, it was 0.1, 0.07, 0.17, and so forth. It would be the same midpoints you could use across the bottom here. And the frequency would just be counting by 0.1, 0.2, 0.3. But what you will notice when you start to do it is you'll notice the same hills and valleys when you go to create it. You'll see the same pattern emerging from the previous graph. It would look identical. The only thing that changes is the scale on the left-hand side. So a cumulative frequency graph is a line graph that displays the cumulative frequency of each class at its upper class boundary. The upper boundaries are marked on the horizontal axis, and the cumulative frequencies are marked on the vertical axis. So you might want to create a histogram in order to be able to see perhaps the spread of a data set or the shape of it, whether it would be symmetric or skewed. So I've listed here the steps to putting your data set in your calculator. So if you have a data set, you could go to stat and then enter, and you would type all of your midpoints in list 1 because you can't type in lower and upper class limits. So we use midpoints, and then you would type all of your frequencies in list 2. You would click second and then stat plot, which is above the y equals. So this is one button together, second stat plot. And you would want to turn on plot 1. You would turn it on by clicking enter on it. You can highlight the histogram option, which looks like a little bar symbol. Make sure it's set for list 1, list 2 for your data set. And then zoom 9 is how you can now see the graph. Zoom 9 is going to go into your data set and it will automatically create the window so you get the perfect image of the whole thing. While you're looking at the graph, you can click the trace button and the midpoint and the frequency of the first class will be displayed at the bottom of your screen. If you use your left and right arrows, you can switch between each bar of your histogram to see for each one of them the midpoint and the frequency for ease of doing your homework or finding some answer.